Have you ever wondered what would happen if a massive comet, specifically a cryovolcanic one, exploded in space and headed towards Earth? It's a question that lingers in many minds, a curiosity sparked by the vast expanse of the cosmos and the mysteries it holds. Comets, these icy celestial bodies, hold a certain enigma. Their potential impact on Earth, whether in the distant past or the unforeseeable future, is a subject of intense debate and speculation. Today, we delve into this fascinating yet terrifying prospect. Our story begins with the discovery of a unique comet. The year was 2023, and it was an ordinary night at the International Space Observatory. Dr. Aria Kepler, a renowned astrophysicist, was on her routine survey of the cosmos. That was when she spotted something extraordinary, a faint gleam of light, far out in the uncharted abyss of the universe. This was the birth of the discovery of the comet we now know as Cryovolcano. The comet was named for its unique cryovolcanic nature. Unlike common comets, which are composed of rock and ice, this one was different. It was made up of a rare blend of frozen gases, including methane, ammonia, and water. But what truly set this comet apart was its volatile activity. Cryovolcanoes, or icy volcanoes, erupted from its surface, spewing these frozen gases into the cold expanse of space, creating a breathtaking spectacle of icy plumes against the cosmic backdrop. As the world watched, Dr. Kepler and her team took this as an opportunity to dive into the study of cryovolcanism in greater detail. They were intrigued by the prospect of understanding the mechanisms that could cause such an eruption in the frigid, harsh environment of space. The comet became a subject of intense scrutiny, with scientists around the globe waiting eagerly for the data from the observations. Time and again, the cryovolcano comet defied our understanding of space and its celestial bodies. It served as a reminder of how much we still have to learn about our universe. The scientists were fascinated, the world was captivated, and the comet continued on its journey, silently cruising through the vast expanse of the cosmos. However, just when we thought we were starting to understand this cosmic traveler, it threw us another curveball, something that no one saw coming, something that would change our perspective on comets and their behavior forever. But then something unexpected happened. The comet exploded. The peaceful journey of the comet was disrupted by a powerful explosion, an event that, in the grand scheme of the universe, was as sudden as it was dramatic. But what caused this celestial detonation? The answer lies in the unique nature of the comet itself. Our comet is a cryovolcano, a volcano that erupts with volatile materials such as water, ammonia, or methane instead of molten rock. These materials, frozen by the harsh cold of space, make up the core of the comet. As it approached the sun, the heat caused these volatile materials to sublimate, turning directly from a solid state to a gas. The resulting pressure buildup led to an explosion, tearing the comet apart in a spectacular display of cosmic fireworks. Now, let's consider the aftermath of this explosion. The force of the eruption was so powerful that it altered the comet's trajectory. Prior to the explosion, the comet was on a harmless journey, set to pass by our planet at a comfortable distance. But the explosion acted like a cosmic billiard shot, pushing the comet onto a new path. A path that, worryingly, intersects with our own orbit. In the blink of an eye, a simple comet has become a potential threat to our planet. Fragments of the explosion, varying in size from dust particles to chunks as large as mountains, are now hurtling towards us. These fragments, traveling at high speeds, have the potential to cause significant damage upon impact. As these fragments make their journey towards us, our scientists are working tirelessly to gather as much data as possible. Every piece of information brings us a step closer to understanding the potential impact and preparing our response. With the Earth in its path, the question arose, what can we expect? This question marks the beginning of a new chapter in our story. A chapter that will require us to delve into the potential impacts of such an event and explore the ways in which our planet might defend itself from this celestial intruder. The potential impact of such an event is both fascinating and terrifying. Imagine a massive comet, a cosmic snowball of frozen gases, rock, and dust, hurtling towards Earth. It's a scene straight out of a science fiction film, isn't it? But what if this sci-fi scenario became a reality? What kind of changes could we expect? Let's start with the environmental impact. If a comet the size of a city were to collide with Earth, we'd see an explosion equivalent to billions of atomic bombs. The energy released would vaporize everything in the immediate vicinity and create a crater hundreds of miles wide. Dust and debris would be flung into the atmosphere, blocking sunlight and causing temperatures to plummet. We'd be plunged into what scientists call a nuclear winter, a chilling echo of the Ice Age. The climatic changes wouldn't stop there. The dust cloud would also trigger acid rain worldwide, devastating plant life and water sources. And if you think that's bad, the shock waves from the impact would trigger earthquakes, tsunamis, and volcanic eruptions, adding to the global devastation. But what about the impact on life itself? Well, we only need to look back to the dinosaurs for a glimpse of what might happen. 65 million years ago, a comet or asteroid impact is believed to have caused a mass extinction, wiping out 70% of all species on Earth. If such an event were to occur today, the human race could very well be on that extinction list. Past comet impacts have left their mark on our planet, both literally and figuratively. The Chicxulub crater in Mexico, the Sudbury Basin in Canada, and the Redefort crater in South Africa are all scars from these celestial battles. They serve as silent reminders of the destructive power of these cosmic intruders. So, faced with this impending threat, how prepared are we? In the face of a potential cataclysmic event, mankind's survival instincts kick in. Our species, in its relentless pursuit of survival, has developed a variety of planetary defense mechanisms, hoping to safeguard Earth from celestial threats, such as comets. Our first line of defense is detection and tracking. Organizations like NASA's Planetary Defense Coordination Office and the European Space Agency's Space Situational Awareness Program scan the skies constantly, identifying and tracking near-Earth objects or NEOs. These agencies use advanced telescopes and radar systems to monitor any celestial bodies that could pose a threat to our planet. But what if an incoming comet, like the cryovolcanic one we're discussing, is detected? That's where our next line of defense comes in. Deflection. The idea is to nudge the comet off its earthbound trajectory. NASA's DART mission, set to launch in November 2021, aims to demonstrate this capability by intentionally crashing a spacecraft into a moonlet of a binary asteroid system. However, the success of such a mission against a cryovolcanic comet is purely theoretical. These comets spewing icy volcanic eruptions are more volatile and unpredictable than typical asteroids or comets. The force required to deflect it might be significantly higher, and the risk of causing a fragmentation, which could lead to multiple impact events, is a real concern. The final and most drastic defense mechanism is disruption. This involves the use of nuclear explosives to obliterate the threatening body. This strategy, while dramatic, is fraught with its own set of challenges and controversies, but could be a last resort in a dire situation. While our preparations may seem robust, the unpredictability of space continues to loom over us. Our defenses, though technologically advanced, are still in their infancy. As we gaze into the cosmos, we're reminded of our vulnerability and the importance of continuous research, preparedness, and cooperation in the face of such universal threats. As we stand on the brink of a potential cosmic event, let's summarize what we've learned. We started our journey with the discovery of a fascinating phenomenon, a massive cryovolcanic comet, a rare celestial occurrence that had scientists across the globe buzzing with excitement and curiosity. This comet, unlike anything we've encountered before, added an unexpected twist to our tale when it exploded in the vast expanse of space. The aftermath of this explosion, a spectacle of extraterrestrial fireworks, is now on a trajectory towards our home planet, Earth. We've delved into the potential impact of this event on Earth, a scenario that, while unlikely, could have far-reaching consequences. We've explored the possible effects on our climate, our technology, and ultimately, life as we know it. Of course, we're not merely spectators in this cosmic drama. We've also examined Earth's defense mechanisms, our planet's own protective shield, and the theoretical likelihood of human-made weapons to deflect such a threat. This journey through the cosmos has reminded us of the immense power and unpredictability of the universe. But it has also underscored our growing capacity to understand, predict, and even potentially influence cosmic events. In the grand scheme of the universe, we are but a small part, constantly learning and preparing for what the cosmos might throw at us.